Okay, still people are coming. Okay, we'll see. Anyways, so last time we started probability and we did a lot of questions related to probability. So today I'll just give you a brief introduction first. Okay. So in probability, last time we discussed about the outcomes, let's say for coins and dice, cards, and then we also covered multiplication rule and addition rule. So just for your reference, so P A intersection B is equals to P of A times P of B. So in probability, when you talk about probability of event A and B together, let's say. So you are saying and, or you will see and in the question. So you need to use a multiplication rule. So and means multiplication. And if you see or in the question, then you have to use plus. You have to add the probabilities. So what is the addition rule in probability? Probability of A union B equals to probability of A, probability of B minus probability of A intersection B. So this is what we studied last time, isn't it? And the similar expression you studied in set theory. So I already gave you an example last time how it is similar to set theory, isn't it? And so this is called addition rule and this is called multiplication rule. Now multiplication rule actually came from conditional probability. So what was conditional probability? Probability of A. Now this is a vertical line, so you have to be careful. And P of A intersection B over probability of B. So probability of A is depending on probability of B. And this is called conditional probability. Now, conditional probability, this is the formula for conditional probability. But if you consider that if you consider A and B are independent events, independent events means occurrence of one event does not depend on the occurrence of the previous event, let's say, isn't it? Or on the other event. Then they are called independent events. So in that case, probability of A vertical line B can be written as probability of A because it is not depending on probability of B. So this conditional probability formula converts into multiplication rule, which is probability of A multiplied by probability of B. That will give you probability of A intersection B. So you need to keep all this in mind, and they will give you some information in the question. So from that you need to make sure you use the right formula. But these are the important formulas in probability. Now the next thing which we studied is, which is very important, Bernoulli trial. So what is Bernoulli trial? So Bernoulli trials means you are kind of repeating the same experiment, isn't it? That's why it is called trials. It's more like a scientific word. So when you do the same experiment again and again, okay, it's called trials. So same experiment you're repeating, and the probability is given by NC or small p to the power or q to the power n minus r. So this is the formula for Bernoulli trial, where n represents the number of trials and r represents the number of success. Okay. So let's say you flipped coin 100 times. Okay. And you want 30 heads. So 30 times you want heads. Okay. So heads will be considered as your success. Okay. So n is 100 in this case. So that's the number of trials. R is the number of success. You want 30 times head, isn't it? So R is 30. Small p. So what is small p? Small p is the probability of success. In this case, it is 1 over 2, isn't it? Probability of getting head is always 1 over 2 for one coin, let's say. And Q is probability of failure, which is generally 1 minus P. So in this case, it's 1 minus half will give you half again. Okay. So that is a relation between P and Q. So P plus Q is equals to 1. If you know one probability, you can find out the other probability using this expression. Okay. So this is the formula for this is the formula for Bernoulli trial, and you should know what are the different terms here. N is the number of trials, R is the number of success, P is the probability of success, and Q is the probability of failure, which can be calculated as 1 minus P. Okay. So that is all about what we did earlier, and I hope you watched or revisited the video which we did earlier. Okay. So I think some questions we already covered. Let me see. I think we did this question already. This is the question which we did last time, isn't it? I think we covered that already. Okay, so let us maybe try this question. So this is 2013. Question number 1, part B. So in a class of 30 students, 20 students study physics, 6 study biology, 4 study both physics and biology. So what you need to do, you need to express this information in the Venn diagram. So if we remember the concept of set theory, you can easily do this question. Okay. So first of all, let us draw this. Something like this. This is physics. This is biology. So total number of students are 30. Total students is equal to 30, isn't it? So in the set theory, you probably did this type of question, like theoretical question or word problem, you can say, where they will give you all the information and they will ask you to put all the numbers in the Venn diagram, isn't it? And in order to do this type of question, we always start from the intersection point, okay, or intersection space or a common space. So 4 students study both physics and biology. So you need to put 4 here. So we always start from the common area, okay, when you do these kind of Venn diagram questions. Now, what you left with? Physics. So they said 20 students study physics. 20 students study physics. So total number of students who study physics is 20, but 4 you already considered here in the middle, isn't it? So you left with 20 minus 4, 16. So total it should be 20, like this. That's why you have to start from middle instead of repeating that. Biology, 6 students study biology. So you already have 4 there. So you should have 2 here, isn't it? And now we want to also find out if there is any students outside physics and biology region, okay, or they do not study physics and biology or biology. So how will you do that? 16 plus 4, 20, 20 plus 2, 22. So this is 22, but the total student should be 30. So how many remaining? 8. So you need to put 8 students here. Okay. So this is how you need to write down the information in the Venn diagram. So that's the first part of this question. A student is selected at random from this class. What event A? Event A is the student studies physics. And event F means the student studies biology. So they are selecting one student from this class. If they found that the student selected is studying physics, then we will say that event E is occurring. And if they pick a students who study biology, then we say event F is occurring. Okay. You need to find out whether E and F are independent or not. Are they independent events or not? Okay. So how will you prove that? So I already explained you that whenever you see this word independent events, you need to use multiplication rule. So the multiplication rule is E intersection F should be equal to probability of E times probability of F, isn't it? This is according to the multiplication rule. And if two events are independent, then they must satisfy this equation. So first of all, we will use, let's say, the left hand side, and we'll find out what is the probability of E intersection F. So how many students study both biology and physics? It's 4. Okay. 4 out of total is 30. Now we are finding the probability, isn't it? So 4 students study both physics and biology, and total students are 30. So the probability is 4 over 30. Okay. Next, let's use right hand side. And right hand side is probability of E times probability of F. Probability of E times probability of F. So what is the probability of E? E means the student who studies physics. So there are 20 students which study physics. So 20 out of 30. What is the probability of F? So how many students study biology? 6. So 6 out of 30. And then you can simplify this. So how will you simplify this? Well, you can use calculator. So I'll just do it straight away. Sorry, 0, 0 cancel, and 3 to the 6. So it will give you 4 over 30 as well. So you can see that left hand side and right hand side are equal. So both event E and F, they satisfy the multiplication rule, and therefore they are independent. Okay. So keep in mind that when they talk about independent events, it means it is related to the multiplication rule. Okay. So let's move on to the next part. Okay. Now this is the question which we need to do, and it's very common in the exam. So this is 2014 question number 3. Okay. Okay. So how will you do this type of question, and what's the idea behind that? Two different games of chance shown below. There are two games, game A and game B, as you can see in the figure, and they can be played at a charity fundraiser. In each game, the player spins an arrow on a wheel and wins the amount shown on the sector that the arrow stops in. Okay, so I hope this is clear to everyone. So you just spin it, and let's say if it comes at €5, you will win €5. If it comes at €6, you will win €6. If it stops at €0, so you will win nothing. Okay. Each game is fair in that the arrow is just as likely to stop in one sector as in any other sector. So it's a fair possibility. Okay. Why? Because each sector here measures the same angle at the center basically. So you know the sector. Sector means it's part of the circle. So let us say this is the center of the circle. So this is called sector. Okay. You can have another sector here. You can have another sector here. You can have another sector here, isn't it? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So basically all these sectors are equal in area basically. That's why they said there's a fair chance that it will stop at any particular number. Okay. Now, question starts from here. John played game A 4 times and tells us that he has won a total of €8. So John played game A 4 times. So he basically spin 4 times and he won total of €8. In how many different ways could he have done this? So basically, let's say you spin this and you got 4 chances. So the total amount you should win is €8. So how many different ways are possible? Anybody can guess? What are the different ways possible here? What are the different ways John can win €8 in total? For example, one way is in the first attempt, let's say he won. So all you need to think is if you add some numbers here, you should get 8, isn't it? Based on game A. So 3 plus 5 is 8, isn't it? So he can win €3 in the first attempt, isn't it? €5 in the second attempt. Then he got 0, 0. So the total is 8. 3 plus 5 plus 0 is 8, isn't it? That will give you 8. And then what? How will you list all the possible ways? Any idea? How will you find out quickly the total number of ways? You need to go by logic because otherwise these kind of questions in the exams will take a lot of time, although it looks easy. But we don't want to spend a lot of time on this question, isn't it, in the exam? So what you need to think here is that the total 8 is required. Total of 8 is required. So which two numbers or three numbers you would add to get 8, isn't it? So according to the number you have 0, 0, 3, 5, 6, isn't it? And there is 6 cannot be added to any number like 3 or 5 to get 8, isn't it? So there is only one possibility. It's a combination of 3 and 5. But 3 and 5 can occur at different um, you know, spins. So how will you do that? So you need to list all the possible outcomes here, because in the question they said how many different ways could he have done this? Okay. So how will you do that? 0, 0, sorry, 0, 0, 3, 5. You can say 5, 0, 3, 0, isn't it? So there are many different ways, but how will you write down the total straight away? 5030, 5003, 350 already consider already 3500. So 5300. Okay, 5300. 5030, 5300, and then you can use 3050, 3005 and 0530 0503 0053, which is basically opposite of this, isn't it? And 0350 0305 and 0035 we already considered. So 1 2 3 4 5 6 7 8 9 10 11 12. So there are total 12 ways possible, isn't it? But you need to play with 3 and 5. Okay, next part of this question: to spin either arrow once, the player pays €3. So to play the game, you have to pay €3. Well, which is obvious. This is a charity fundraiser event, isn't it? If people will not play, if people will not pay you to play this game, then how will you raise the fund? That's the idea. So they have to pay €3 to play the game. And for example, if somebody got 0, it means you got €3 for the charity, isn't it? So which game of chance would you expect to be more successful in raising the funds for the charity? Give a reason for your answer. So which game A or game B, would be more successful in raising funds for the charity? So how will you find out? So in these type of question, what you need to do is called expected value. You need to find out the expected value, and the formula for expected value is sigma x times px, where x is the variable, let's say, whatever variable is there, and p is the probability. Okay, so the best way to do that, you need to do this for both. Okay, so for example, let's talk about game A. For game A, what are the variables there? You have €0, €0, €3, €6, and then 0, 3, 6 and 5. So you have 4 variables. You don't need to write 0 again because you're just talking about the value, isn't it? Now you write down the probability of each of this number. What is the probability of getting €0 in the game A? Okay, how will you find out? So it is total number of sectors are 5, total 5 sectors, but out of 5, 2 sectors have €0, isn't it? So it is 2 over 5. 3, 1 over 5. 6, 1 over 5. And 5, 1 over 5. So these are the probabilities of each of the sector, isn't it? Or the number. And what is the formula for expected value? X multiplied by px. So you need to multiply that. So when you multiply 0 by 2 over 5, you will get 0. This will give you 3 over 5. This will give you 6 over 5. And this will give you 5 over 5, let's say, isn't it? And sigma is the symbol for summation. Summation means sum. Okay? Sigma means sum. So when you add all of them, all these numbers, you will get the expected value. So sigma x px equals to 0 plus 3 over 5 plus 6 over 5 plus 5 over 5. So I'm just writing in this way because you can get the answer quickly. So the LCM is 5. 6 plus 3 is 9. 9 plus 5 is 14. So you'll get 14 over 5. If you want, you can change it into decimal. So what you will get? 5 to the 10, 5 8 the 40. So 2.8 euro. So what is this expected value? This expected value tells you that if you play this game, you expect it to raise 2.8 euro. So you are in loss actually, because you are asking people to pay 3 euro and they expected to win 2.8 euro, isn't it? So you won't make much money out of this. So the difference is 20 cents, isn't it? But let's check game B first, isn't it? Before we conclude that, let's check for game B. So for game B, you have 0, 1, 2, 3, 4, 5. 0 euro, 1 euro, 2 euro, 3 euro, 4 euro, 5 euro, isn't it? You have all the options. And what is the probability of that? What is the probability of getting 0? 1 over 6, because you have 6 sectors now. Okay. Total you have 6 sectors. For 1 also, 1 over 6, 1 over 6, 1 over 6, 1 over 6, and 1 over 6. You can see that all numbers are different, isn't it, in each sector. So therefore, the probabilities are 1 over 6 for all of them. And when you multiply, what you will get? So when you multiply, what you will get? X multiplied by px. You will get 0 here. You will get 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6. And then you need to add them. In order to add them, you can see that the denominators are same for all. So I'll just write down 6. And 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. So what you got? 15 over 6. Now what is 15 over 6? So 6 to the 12 point. How much? 5, isn't it? 2.5 euro. So this difference is 50 cents, isn't it? So it means 50 cent is the difference between what you expected to get and what they're paying, isn't it? So game B pays out less money. Okay. So you need to take the difference at the end between what you got as an expected value and what you got, what they are paying for playing the game. Okay. Now the part C of this question. Mary plays game B 6 times. Find the probability that the arrow stops in the sector which gives her €4 exactly twice. So she's playing game B 6 times. Okay, and 2 times she should get €4 in game B. Can anybody guess how we can do this question? So Mary is playing game B and she's spinning 6 times. 2 times exactly. So Grace said Bernoulli trial, and you can see that it is Bernoulli trial here because you are doing or spinning 6 times, and it's the same experiment, isn't it? You're doing the same experiment 6 times, and out of 6 times, 2 times you want success. Well, the success means whatever is given in your question. It depends on that. Okay, so what is the formula for Bernoulli trial? NCR small p to the power or q to the power n minus r. Now, what is the probability of success? Success means what is the probability of getting €4? Well, it's 1 over 6, isn't it? And what is the probability of not getting €4? 1 minus 1 over 6, which will give you 5 over 6. So, n is 6, c r, which is 2, p 1 over 6 to the power r, which is 2, q is 5 over 6 to the power 6 minus 2, which is 4. Okay, and then you can use calculator to solve this question. Okay, but that is the probability you will get. Okay, so this is the example of Bernoulli trial as well as the expected value, and it's very easy, very easy. All you need to do is list out the variables. Main thing is the probability. Your probability has to be correct. Okay, once your probability is correct, you just multiply. You'll get x multiplied by px column, and then sigma means add them. Once you add them, you will get the expected value for that question. Okay, and that's the Bernoulli trial. So I hope that is clear now. Okay, so now this is about hypothesis and all, so I need to cover that topic, and that is in statistics. So this is kind of mixture of everything. So that's why I'm not doing this at the moment. So let's see what is left now. I think we haven't done this question, so let's try this question. This is 2015 paper, question number 8. In basketball, players often have to take free throws. Okay. So when Michael takes his first free throw in any game, the probability that he is successful is 0.7. Okay. So they already gave you that probability of success. For all subsequent free throws in the game, the probability that he is successful is 0.8 if he has been successful on the previous throw, and 0.6 if he has been unsuccessful on the previous throw. Now, little bit tricky, so you need to understand this. When Michael takes his first free throw in any basketball, okay, so the probability of success is 0.7. So let's say this is success. Okay, and he's throwing again, and if he got a success, If he has been successful on the previous throw, which he is, isn't it? Then this probability has to be 0.8. Okay, like that. And then let's say he is successful again. So what is the probability now? Because he was successful in the previous throw, so you have to use probability equals to 0.8. And that is the answer for the first part of this question. You need to find out the probability for the first 3 free throws, and it's success, success, success. So for the first success, the probability has to be 0.7. Read the first sentence here. When Michael takes his first free throw in any game, the probability that he is successful is 0.7. Okay, so this is the first throw, and if he is successful, then this the probability is 0.7. So that's why it starts from 0.7. Next, second and third throw, if he wants to be a successful, then the probability has to be 0.8 because in the previous throw he was successful. Okay, so this is the answer for the first part, probability of SSS. Let's try the next one. Find the probability that Michael is unsuccessful with his first 2 free throws. So PUUS. So you already know that for the first throw, the probability of success is 0.7 for the first throw. So what is the probability that the Michael is unsuccessful in the first throw? It's 1 minus 0.7, which is 0.3. So that's why the first one is 0.3. Next, again unsuccessful. Now, again unsuccessful. So it's given there in the question. The probability that he is successful is 0.6 if he has been unsuccessful on the previous throw. But 0.6 is the probability of success in the second throw. So probability, let's say it's U and now S. So the first one was, let's say 0.3, and then they are saying probability of success is 0.6 if the previous one is unsuccessful throw. Okay, then you have to use 0.6. But in your question, it's not success now, second time, it's unsuccessful. So 0.6, again you have to do it as, so I'll write down here for your reference. This is 1 minus 0.7 times 1 minus 0.6 now, which will give you 0.4. And the last one is success. Now you can use this, okay, because probability of success is 0.6 if he has been unsuccessful in the previous throw, which was this. Okay, so this was unsuccessful, so that's why this is 0.6. So this will give you answer for this question. Okay, I hope it is clear. So you have to read the question carefully, the information which is given in the bullet point here, so that's very important. Now list all the ways that Michael could be successful with his third free throw in a game. Okay, third time he has to be successful. Find the probability that Michael is successful with his third free throw. So this is fixed. Okay, in the third free throw he has to get a success, but you need to find out the total probability, and total probability is based on what you consider in the first 2 attempts. First 2 attempt could be anything. So what are the possibilities for the first 2 attempt? Well, you can get success, isn't it? You can get unsuccessful in the first two attempt. You can have success, unsuccessful, or you can have unsuccessful and success. I'm just talking about the first two attempt because the third attempt is success. It has to be success, isn't it? So in the first two attempt, you can get success or unsuccessful, successful at the first throw but unsuccessful for the second throw, unsuccessful for the first throw and successful for the second. So you need to systematically do that like we do for coins. Okay, and based on that you can find out the probability. Okay, so all you need to do is find out the probability of this this and this. So what is the probability of success? We already calculated here, which is 0.7 by 0.8 by 0.8. So I'll write down directly like this. And there is one more we already calculated, which is unsuccessful, and successful, which is UUS part B, which is 0.3, 0.4, and 0.6. Now, can you guys calculate these two and tell me the answer? So calculate for probability of success, unsuccess, success. SUS. What would be the probability? Don't give me the final answer. I want answer in terms of individual probabilities, basically. Lauren said something. Can you split into numbers like this? What exactly is the probability you have taken? What is the individual probability for SUS? SUS. So first is 0.168. Anna said 0.7. Okay, let me see. Okay, let's see. Success. First throw is successful, which means 0.7. Agree? Second one is unsuccessful. And Anna said 0.2. Okay, let's see. So second one is unsuccessful, isn't it? So what is the probability of that? So he is successful. If I'm reading the bullet point, he is successful is 0.8 if he has been successful in the previous throw. But this is for unsuccessful. So this should be 0.2, isn't it? Probability of success is 0.8, but we want probability of to be unsuccessful. And then he is successful here, but in the previous throw he was unsuccessful. So that should be 0.6. Let me see what was the answer, sorry. 0.7, 0.2, 0.6. Yes. Exactly. Now Anna said 0.7, 0.2, which is correct, but the last one you're saying 0.8. Why 0.8? No, it should be 0.6 because in the previous throw he was unsuccessful, isn't it? So in when you take 0.8, the previous throw was successful, isn't it? So it has to be 0.6. Agree? And the last one, what about USS? So first one has to be 0.3 because it is unsuccessful, isn't it? Next one is successful, but the previous one is unsuccessful. So I can copy that 0.6, isn't it? And then it is successful and the previous one is successful as well. So that is 0.8. Okay. Okay. So you just have to use the information properly. Okay. Now we want total probability. Okay. So what you're writing here, you are writing the possibilities. This is one possibility and I'm using the word or. This is the second possibility. I'm using the word or. Third possibility or. Fourth possibility. So what word I'm using here? Or. So at the end, you need to find out the total probability and you need to add them all. So you need to add all these answers because it's or. And reason we are multiplying here, why we are multiplying 0.7 by 0.8 by 0.8? Because we are saying first throw is successful and second throw is successful and the third throw is successful, isn't it? So I'm using and here. I have to use and because it's part of one experiment, let's say. So you throw 3 times, first success, second success, and third is success, isn't it? So that's why we are multiplying there. But overall, these are 4 possibilities. So 4 possibilities means only one can occur at one time, isn't it? So that's why you need to add them. Or means plus, and means multiplication. Okay, so there are more questions here. Part D. Let Pn be the probability that the Michael is successful with his nth free throw in the game. So Pn is the probability for nth free throw and it's the probability of success. Nth means it can be any throw, any number of throw. It can be 4th, it can be 5th, it can be 10th. So it's a generalized version of that. And therefore 1 minus Pn would be the probability of Michael to be unsuccessful with the nth throw, nth free throw, but unsuccessful. Okay. Show that Pn plus 1 is equal to 0.6 plus 0.2 times Pn. So what do you mean by n plus 1? N plus 1 means it's the next throw, probability of the following throw. So whatever you consider for n, if you consider n as 10th throw, then this should be the 11th throw. Okay, so how will you find out that, or how will you prove that? So what we need to do is we can write down the probability of n plus 1th throw, okay, which you can consider as 11th throw, which I'm writing here, isn't it? If you're talking about 11th throw, and what is this 11th throw? 11th throw is successful, isn't it? 11th throw is successful, let's say. So there are two possibilities. 10th throw, which we are talking about here, may be successful or it may be unsuccessful. So the probability of n plus 1th throw, I can write down as PSS plus PUS. This represent n plus 1th throw, this one as well, and this represents nth throw. Okay, but Pn plus 1 is the probability of success for n plus 1th throw. Okay, but there are two possibilities. So again, I'm using or. Nth throw can be successful or it can be unsuccessful. So I need to add their probabilities. Now, PSS. What is the probability of PSS? So probability of nth throw to be successful, it's given in the question, which is Pn, isn't it? And what is the probability of n plus 1th throw then? It should be 0.8. If you see the question, if Michael is successful, then the probability is 0.8 if he has been successful on the previous throw. So that's why it is 0.8. Similarly, here also, the first throw is unsuccessful. First means nth throw is unsuccessful here. Unsuccessful. What is the probability of unsuccessful? 1 minus Pn. And the next one is successful. Successful, but the previous one was unsuccessful. So what is the probability? It's the second bullet point there, and that is 0.6. Okay. This is how you need to do it. So first I'm writing two possibilities, and then I'm writing their probabilities, and then you just simplify this. So 0.8 Pn, and if you multiply 0.6 inside the bracket, you will get 0.6 minus 0.6 Pn. So you'll get 0.6, 0.8 minus 0.6 is 0.2, so 0.2 Pn. So Pn plus 1 can be written as this. Okay. So the n plus 1th throw is successful, but the nth throw can be successful or it can be unsuccessful. So based on that, I'm writing 2. Okay. Okay. Okay, so the next part is this one. Second part. What is the second part? Assume P is Michael's success rate in the long run, that is for large values of n. And we have Pn plus 1 is nearly equal to Pn is nearly equal to P. Using the result from part D, you need to prove that P is actually equal to 0.75. So first of all, what do you mean by Michael's success rate in the long run? Assuming that P is the Michael's success rate in the long run, and for large values of n, we have Pn plus 1 equals to Pn. Basically, they are saying the probability of success for the n plus 1th throw, okay, is nearly same as the probability of success for the nth throw, okay, on the long run. So how will you find out P and prove that P is equal to 0.75? So you just use the previous equation. and use this approximation which they give you in the question. According to this approximation, you can use Pn plus 1 Pn as P. So put P here and P here as well and solve it. So it's a simple linear equation. So this will give you 0.8 P and then P is equal to 0.6 over 0.8 and 0.6 over 0.8 is equal to 0.75. This is how you need to prove it. So you just use this approximation here, substitute in the previous formula which we got, and then get the answer. Okay, so it's a very long question. We'll continue that, but that's pretty much end of probability. Okay, so any questions? Any question, any doubt? Whatever we covered today. What is the difference between mutually exclusive and independent events? And I was asking one question. Okay, so first of all, they can ask you this question in the exam as well. Mutually exclusive events. And what was the second one? Sorry, independent events, isn't it? Yeah, independent events. Now, let us clarify independent events, isn't it? So independent events is related to conditional probability. The concept is connected to conditional probability. So I gave you a simple example last time that if you have 52 cards, okay, and you want to take one card out of this, and I want to say what is the probability of, let's say, getting a jack. So you will say 4 over 52, isn't it? Then I take another card and I'm asking you again, what is the probability of getting a jack? Now there are two possibilities. The last one, or the last, let's say, card was jack. Then the probability would be 3 over 51 now, isn't it? And if it was not jack, then the probability would be 4 over 51, isn't it? So you can see that the probability is different depending on the outcome of the first event, isn't it? So this is called conditional probability. And that is the reason we write, let's say, probability of A dash B is equal to A intersection B over probability of B. Okay. So probability of A is depending on the probability of B, basically. Okay. So this is called conditional probability. Now, independent event is the special case here, and which is, what is the meaning of that? Meaning of that is the probability of one event is not depending on the other event, which means two events are independent. So this is equal to probability of A only. And that's why mathematically you will get a multiplication rule here, which is P of A multiplied by P of B. So there is no conditional probability here. Probability of A is not depending on probability of B. And if you look at the question here, which we did today, which is this one. Okay, we proved that these two events are independent. These two events are independent. Why they were independent? Why they were independent? Because you are selecting only one student. This was the key information there. A student is selected at random, and that is the reason these two events are independent. So I am selecting one student. It can be from physics or from the biology, but they are not depending on each other, isn't it? So they are independent events. Occurrence of one event, which is E. E means the student study physics, is not depending on the second event, which is F, and that is for student who studies biology. Okay, so this is the concept of independent events. Now, the second part is called mutually exclusive events. So anybody here answer that? What is mutually exclusive event? What is mutually exclusive events? Okay, mutually exclusive events means if I say probability of A intersection B is simply 0. So the occurrence of A and B together is not possible. Simple. Occurrence of A and B together is not possible, and that is called mutually exclusive events. Okay, so probability of A intersection B is 0. So something like this. This is A and B, but there is no common connection between them, or there is no commons. Okay, so that's the definition of mutually exclusive events. Simple mathematical definition. There is nothing common between them. They cannot occur together. But I have one question now. What is mutually, or you can say exhaustive event? Anybody know about this? What do you mean by exhaustive events? They can occur together. Okay. So you understand mutually exclusive events, they cannot occur together, isn't it? And exhaustive events means when at least one of the events occur compulsorily from the list of events. So if you have two coins, okay, and you can say one head, tail, head, tail. These are the possibilities, isn't it? So this is called sample space, isn't it? This is called sample space for two coins. Head, tail, head, tail. Okay. And exhaustive events means from the list of events. List of events means you can say two heads, you can say one head or one tail, or you can say two tails. These are list of events. So definitely one event will occur from the list of events. Okay, definitely one event will occur from the list of events. So it's not related to whether they can occur together or they cannot occur together. It's a list of events basically. And from this list, one of the event will definitely occur, which means you cannot say the probability is 0. Okay, probability cannot be 0 in case of exhaustive events. Okay, so generally mutually exclusive or independent events they can ask you. I don't know if I haven't seen any question related to exhaustive events, but exhaustive events is the list of events which covers your whole sample space. So nothing can come outside that space basically. Okay. Any other question? So would you like to start maybe statistics next time or any other topic? Because I think now you can practice probabilities and all.